Conservation of momentum occurs in an isolated system. So as an example, let's say we had two ice skaters on frictionless level ice. So the assumption here is that mu is equal to 0 and that the ice is level. And let's say they are pushing on each other. And so there is a larger mass ice skater and a smaller mass ice skater, and the larger mass ice skater pushes to the left on the smaller mass ice skater. So there's a force of big M on little m, and by Newton's third law, there is therefore a force of the smaller ice skater pushing on the bigger ice skater, F of little m on big M, and these two forces are equal and opposite to each other. There are no external forces on the system of little m and big M together. The forces in the y direction on little m add to 0. The forces on big M in the y direction add to 0. And the only forces acting on big M is from little m, and the only force acting on little m is from big M, but those are internal to the system, and therefore the external forces are 0, and then we can say that momentum is conserved. So for example, to be concrete, let's suppose that little m was 50 kilograms and big M was 100 kilograms, and that the velocity of the small mass was minus 3 meters per second after the push. We can use conservation of momentum to figure out what the velocity of the larger mass ice skater was. Initially, we know before they started pushing on each other that their total momentum was 0. In fact, Vmi and V big Mi are both 0 if they stand stationary with respect to each other and start to push. So initially the momentum is 0. That means that finally the momentum has to be 0 by conservation of momentum. And we can therefore set the final momentum equal to 0. We can then isolate VMF, V big MF. The little f stands for final here, and so the final velocity of big M is the negative of little m over big M times the final velocity of little m, and so that's minus 50 kgs over 100 kgs times minus 3 meters per second, which means that the final velocity of big M is 1.5 meters per second to the right.